So it's a very interesting question and very difficult question also. It's not simple to solve this question. Uh, only a student, only if a student is very uh, good and he knows or she knows all the fundamental concepts, all the fundamental rules of the conductor, then only this question can be solved. So I'll put this question in a question of extraordinary category, and this will be solved only by extraordinary students. So we are given that there is a neutral conducting spherical shell and an external electric field is applied here. Now this is the center of the conducting shell, and Q is an additional charge which is kept inside the spherical shell. Let us go by options. Option A. In option A, they are saying that force on Q due to E is 0. Due to this E, force on Q will be 0. Generally, a student thinks that because there is a rule that outside electric fields cannot enter the metallic shell. And by this rule, students sometimes make a mistake that this E will not exert force on this charge Q. This is a general mistake which many students commit this mistake. The mistake is due to not knowing the rule very correctly. The rule says that resultant electric field inside this will be 0 due to all the charges present outside the shell. So due to this E, and the charges will be getting induced on this outer surface of the conductor. They may be minus, 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 plus, plus, plus here, something like that. So electric field due to this and electric field due to these charges which are outside, due to both of them, electric field here will be 0. So electric force due to all of them on this charge will be 0. Electric field due to this E alone on this Q will not be 0. F on Q due to E will be a normal answer. It is Q into E. So in the option A, they are saying that force on Q is 0. This is not correct answer. Let us come to B. This is right thing. F on Q due to E will be QE, but they are saying that F on Q is 0, so the option A will not be correct. In the option B, they say that net force on Q is 0, given F net is 0 on Q. Now, again, there will be a misconception that due to all these outside charges, force on Q is 0. Only by this impression, students sometimes conclude that resultant force on the Q is going to be 0. But this is wrong. There is third charge also. These are two charges, and there will be another charge minus Q sitting on this inner surface. This will be induced charge. Now this minus Q charge which is present on the inner surface will be non-uniformly distributed because it is not kept at the center. This non-uniformly distributed charge will exert force on Q, so resultant force on this Q will not be 0. So this is given, but correct answer is F net is not 0 on Q, minus Q induced on inner surface will exert force on Q. This is the reason of this. So B is not answer. F net 0 on Q will not be the answer. Now come to the C option. What they are saying in C, let us see. C option. C is net force acting on Q and conducting shell considered F net on Q plus shell will be 0. This is what the option says. But our explanation is this is Q, this is minus Q, this is plus Q. Now, there is an electric field E, Due to this E, there will be force on Q towards right. There will be force on minus Q towards left. There will be force on Q towards right, QE. So there are two QE and there is one QE on left. So F net will be Q into E on this whole system by this external electric field. It is not 0, so C is also wrong. So A is not answer, B is not answer, C is not answer. By the objective style, D has to be the answer. But still I will explain that why D is the answer. But as far as the objective pattern is concerned, you don't have to now prove that D is the answer. D is automatically answer. But let me explain this. The D option says that net force acting on the shell is 0. F net is 0 on shell due to E, and it is absolutely right. How it is right? Minus Q plus Q. This is the electric field. This E will exert QE on plus Q. This E will exert QE towards right on minus Q, and F net is 0. So D is a correct option. So final answer to this question is only D. A, B, C are not correct options. So that is how, since it uses so many concepts of the metallic bodies. It's a very good question for revision. Students must come at this question, revisit this question before going to the exam, which has the syllabus of electrostatics in the papers. It's a good question.